Hey kids, time to do inverse trig graphs. Now, last year we did do inverse trig, but we only evaluated, right? We kind of developed where they came from and we evaluated. We did not graph. This year you were responsible for both evaluating and graphing inverse trig. So firstly, inverse sine. Let's talk about some vocabulary. The inverse sine relation is different than a function. And let me go over here and just remind you, I can relate any two variables by just putting an equal sign between them. This relation is a function because for every time you input 3, you get 9. Every time you input 3, you get 9. At no point when I input 3 do I get something different than 9. However, x equals y squared is a relation, but is not a function, right? Because when you put in 9, you get both 3 and -3, right? So this is not a function, but it is a relation. All it takes to be a relation is for you to equate them. That's a relation. Now, if you remember in AAF, we said, hey, if you know a function is not one-to-one, it will fail the horizontal line test, which means when you switch x and y, you fail the vertical line test. You can get around that situation if you restrict the domain of the original. If you restrict the domain of the original so that your original is one-to-one, you won't have a problem in the inverse, right? So that's what we're going to do with sine. Normal sine is not one-to-one. So certainly when you turn inverse sine, switch x and y, you get something that looks like that, certainly not a function. So what happened was somebody, before either of us were born, took normal sine and chose a piece of it that was one-to-one. There's lots of pieces. This is the one they chose, and write it down. I don't know who they were. They chose a domain. They chopped the domain of sine, which is -infinity to infinity. They chopped it to -π/2 to π/2, where sine is negative and positive. That, of course, corresponds to which quadrants? Yep, 1 and 4. What's the range, by the way? Well, the range was unchanged. The range, right, the radius of the unit circle still goes from -1 to 1. Right, it's always 1, right? It never changes. So what's the domain and range then of the inverse? If that's the domain of chopped sine, the domain of inverse sine, which will be a function because the original is now one-to-one, the domain is -1 to 1, and the range is -π/2 to π/2. So if I make this -1 and this 1, this π/2, and this -π/2, if I plug -1 in here, the inverse sine of -1 is -π/2. The inverse sine of 1 is +π/2. Instead of being concave up, I'm going to be concave down. Inverse sine of 0 is still 0. And instead of concave down, I'll be concave up. And now I can ask you these questions, which I could have asked you before, right? What's the inverse sine of a half is saying who has a sine of a half, positive a half, in my chopped domain. There's only one answer to that. I put in a half and I get π/6. Right? Only one answer. And that's the answer your calculator will give you as well. How about inverse sine of -1/2? -1/2, somewhere here, When you put in -1/2, you only get one answer, and it's not, right, 11 pi over 6. It's negative pi over 6 because of the restrictions in order to make inverse sine a function. Let's do the same. Oh, by the way, sorry, there was no Insta stories. It wasn't like somebody came up with the notation in one place in the world and got it published and everything, and someone else came up with a different notation and got it published, and they posted to their Insta story, and so somebody says, "Oh, I better use that notation." No, there was no such a thing, right? So you just have to deal, right? All right, inverse cosine, same situation. There's cosine, certainly not 1-to-1. Somebody way before us chose a piece where cosine was positive and cosine is negative. That domain is 0 to pi, and that corresponds to which quadrants? Inverse cosine is defined in quadrant 1 and quadrant 2. What's the range? Doesn't change, right? So what is the domain of inverse or arc cosine? The old range. What's the range? The old domain. So inverse cosine of -1 is pi. Ah, terrible drawing, terrible. Again, inverse cosine of -1 is pi. Inverse cosine of 1 is 0. And of course, this should be at pi over 2, right? Inverse cosine of 0 is pi over 2. That's it, baby. Who has a cosine of 1 over root 3? So when I put in 1 over root 3, right, that's 1 over root 2. Couldn't read it. This is in my way. 1 over root 2. 1 over positive 1 over root 2 is here. Is pi over 4. And how about negative? When you put in -1 over root 2, who has a cosine of -1 over root 2? Right? There are actually lots, but by these restrictions, what are you going to put? 3 pi in quadrant 2, 3 pi over 4. Let's do inverse tangent. Hey, what do you think a natural restriction here would be? Right? One of the snakes. Whoa, how come why are these not included? The asymptotes are there, right? Hey, if there are vertical asymptotes on tangent and inverse functions switch x and y, guess what inverse tangent is going to have? Oh, snap! Horizontal tangents. Oh my goodness, it all makes sense. Tangent is negative, tangent is positive. Certainly, who has a tangent of 0 is 0. And then this doesn't have an endpoint, right? It slides along that horizontal asymptote up to 0 and then slides along this horizontal tangent. 2 horizontal tangents, right? not a rational function. Rational functions can only have one. Crazy, right? Oh, I forgot to talk about, sorry, I kind of skipped ahead right to the graph. I was so excited about the horizontal tangents. So inverse tangent is defined in quadrants 1 and 4, just not including the boundaries, right? Because of the asymptotes there, because of the undefined nature. And what was the range? The range of tangent is negative infinity to infinity, right? So what's the domain of inverse tangent? Those cannot be. And what is the range of inverse tangent? The whole domain, right? Pretty cool. You don't have to label these points. If I'm just asking to evaluate, I'm just doing this for emphasis sake, right? So on inverse sine, right? You just, the graph I gave you before I plotted these inside points, right? So inverse tangent, you're done here. Horizontal asymptotes labeled, 0, 0 labeled, appropriate shape with arrows. But if I'm now gonna just to show you again the values that you get when you put in 1. Who has a tangent of 1? So if I put in 1, I'm going to get pi over 4. And who has a tangent of negative 1? What is it? Y equals arctan of negative 1. What is that? What y is going to be? I guess I should put it over here, shouldn't I? Because of the restrictions, you're not going to get, if you went all the way around the circle to quadrant 4, you're going to have to go this way to get to right, for those answers. And your calculator, again, would give you the same results. So let's do a few of these. Sometimes you will be asked these questions without a calculator. This one, you can check with your calculator, but I am asking for degrees. Now notice there's no indicator. The domain values, right, are already ratios. There's no units. So somebody has to tell you degrees or radians, and if they don't, it's your choice. So who has a sine of 1/2? 30 degrees. But if no one said degrees to you, if no one said this and you answered pi over 6, you'd have to be right. Now, what about who has a cosine that is negative? For inverse cosine, what quadrant are the negative values in? Quadrant 2, right? So who has a cosine of negative root 3 over 2? 150 degrees. And again, you can try that in your calculator, put yourself in degree mode. Tangent, where are the negative, which quadrant is inverse tangent defined for negative tangent? Quadrant 4, right? And you can't go all the way around your circle. You have to go backwards. And if you put inverse tangent of negative 1 over root 3 and in your degree mode, you will get negative 30 out of that. Look at these problems. Interesting. There is something cool, and then there's a trap. And it all has to do with the restrictions. So, inverses undo one another, right? The square goes away, the square root goes away, and you just end up with 5. So maybe you won't be surprised that that answer is 30 degrees. And again, if you think about stepping it out, if you work inside out like Aunt Sally taught you to do, the sine of 30 degrees is 1/2. And then what is the inverse sine, right, of 1/2 is 30 degrees, right? So if I realize, oh, inverse sine and sine will undo one another and just drop out the 30, I can kind of skip that step. But be careful. If you just do that whole idea of inverses undo one another and do this, sorry, hun. Can you think about why? Why would that be so? Right? What quadrant is 210 in? 210 is in quadrant 3. I have no problem. I have no restrictions on regular sine, right? So the sine of 210, right? The reference angle is 30. So it is 1/2, but negative. But what is the inverse sine of negative 1/2? Can't be in quadrant 3 because of where I'm defined. Right? So be careful. Oh, I guess I shouldn't say, I guess since this was in degrees, I should say negative 30, sorry. As you can see, my default mode is radians. And again, no one said I had to use degrees, but they gave the original to me in degrees, so I should give it back to them in degrees. Look at this one. This one you certainly can't cancel stuff out, right? You literally do have to work inside out. Who has a cosine of root 3 over 2? Evaluate that part. And you could say 30 because no one's indicating. And then take the sine of that, and I get 1/2, which that kind of sort of should make sense, right? So remember, you have a Unit 5 IB problem. If we were in school, we would have given you 15 minutes to do it, no calculator, but you would have been allowed to use your notes, and it would have been without a partner. But this time, as we said in the directions, it is a very short problem. I hope it doesn't take you any longer than 15 minutes. Please do not use your calculator. You may use your notes, but try without. See if you and your partner, if you do use a partner, see if you can just use your partner. But if you're just with yourself, yes, you may use your notes. All right. Oh, I do love Sheldon, right? From the Big Bang Theory. He does reference inverse tangent a number of times in these episodes. It's pretty cool. All right. Get it? Do you see what that means? What part of an inverse tangent approaching an asymptote don't you understand? Get it? Get it? Right. All right. I will see you in our live session.